All right, so now let's keep using the laws of logs here to expand. So now we've got log base 2 of x times the square root of y there. So I'm seeing, oh, I can expand that out. That's multiplication. Multiplication means addition. So I'm going to pull that x and that square root of y there apart. So I can rewrite that as log base 2 times the square root of y. All right, so now remember you've got that power rule there. Well, that square root of y is actually, the square root of y is the same thing as y to the 1/2. The square root of y is the same thing as y to the 1/2. So notice I put that y to the 1/2 in there. So I'm going to put that up here. The square root of y is the same thing as y to the 1/2. Because it's like there's a 1 here, and there's like, we don't put the 2 out here, but it's kind of like there's a 2 there, so it becomes y to the 1/2. Because if this was the, let's say this was the cube root of y, well, if it was the cube root of y, there's like a 1 there, and this would become y to the 1/3 power. So now that we can see that, we've got that all written out there. Let's go ahead. I'm going to rewrite log base 2 of x plus, you got to use your power rule now, and this 1/2 here can now come out here in front. So doing that, I get 1/2 times the log base 2 of y. And that's all the farther we can do. We expanded it all out. It went from this short little 1 log base 2 of x times the square root of y to this longer expanded form of that same problem. All right, so now let's come down here and let's look at this natural log problem here. So natural log, the same rules apply. It's still a logarithm. So natural log, and I'm going to pull this apart. I've got the natural log of x times the square root of y over 2. So I'm going to pull this apart plus the natural log of the square root of y over 2. All right, so that natural log of x, I'm just going to leave alone. There's nothing left to combine or do anything else there with. But this natural log of the square root of y over 2, I might go ahead now and pull that thing apart there. So I've got, let me rewrite this. So the natural log here of the square root of, well, let's not do square root anymore. Let's do 1/2. That might be easier. So a square root means 1/2. So natural log of y over 2 to the 1/2. This whole thing, this natural log of y over 2, everything is in there to the 1/2 power. I'm going to pull out that 1/2 power here first. And then I've got this natural log of y over 2 left. All right? Everything in there is to the 1/2. So when I write this, this is going to be the natural log of y, and then it's division in here now, so it's going to be minus the natural log of 2. All right? Everything in there is to the 1/2. That's why I'm putting brackets around that. I want you to see that everything in there is to the 1/2. So you can leave it like that, but if you're going to totally expand it out, we should really go one more step here, and we should say 1/2 times the natural log of y minus 1/2 times the natural log of 2. That would be the proper expanded form there. Natural log of x plus 1/2 times the natural log of y minus 1/2 times the natural log of 2. See, up here, we could have written this as the natural log of y to the 1/2 divided by 2 to the 1/2. So you can see that when you pull it apart, each one of those is going to have a 1/2 out in front of it because it's everything in there is to the 1/2. So that is using the laws of logs to expand there. So now let's go ahead and let's use them to combine. So we've got log base 3 of 5 plus 5 log base 3 of 2. You kind of want to work your rules backwards. So you want to go ahead and use your power rule first here. So I'm going to put my 5 back in there first. In doing so, I end up here with log base 3 of 5 plus log base 3 of 2 to the 5th. And I might even simplify that down. I get log base 3 of 5 plus log base 3 of 2 to the 5th. There is 32. Now I'm seeing I've got this addition sign here. Well, addition sign means multiplication. So I can put this back together as a single log using multiplication. So 5 times 32. Well, 5 times 32, I'm going to simplify that down. That becomes 160. And if you try to do 3 to some power, like set that equal to x and do 3, the x equals 160, well, you're not going to find anything that comes out nicely. So you're just going to leave that as log base 3 of 160. All right, letter B there. Again, the first thing you want to do when you're going to go ahead and combine is you use the power rule first. So put the powers back in. So in doing so, I get the natural log of 5 plus the natural log of x squared plus the natural log of x squared plus 5, and all of that's to the third power. So we're still trying to combine. Notice we have addition signs in between everything left. That's all we have left. We have these addition signs. So addition means multiplication. So let's put it all together using multiplication. So natural log of 5 times x squared times x squared plus 5, and that portions to the third. And I'm going to probably put brackets around this whole thing to indicate that we're going to take the natural log of all of that. And there isn't really anything left to do. We've put that together as a single logarithm, and that's as cleaned up as we're going to need to do. So that's as simplified as we can possibly get it. All right, letter C. You want to put your power back in. So put your power back in first. So I end up getting log base 2 of x to the 5th minus log base 2 of y. All right, now I'm seeing, I put the powers back in there, and now I'm seeing I've got a subtraction sign. Subtraction means division, so I'm going to put it back together using a single log and using division. So I get x to the 5th over y. There's nothing left to do. Notice I don't have a 5th power by the y there. The 5th power only goes with the x. All right, so I've got 3 problems there for you to try out. So pause the video and then take a few minutes and see if you can do those, and then play the video again, and then you can check your answers. All right, so let's combine these. So when we're combining these, we're going to put our powers back in. I see I've got 2 powers there. So this becomes log base 7 of 5 to the 3rd minus log base 7 of x to the 1/2. All right, 5 to the 3rd is 5 times 5 times 5, which is 125. And this x to the 1/2 there is actually the square root of x. And then I see I've got the subtraction sign there. Subtraction sign there means division. So I'm going to put this together as a division problem with a single log. So I've got log base 7 of 125 over the square root of x. All right, letter B. Let's combine these as a single log. Put the 3 back in, put the 2 back in, and there's no power for the last one. So when I do that, I end up getting log base 5 of w to the third plus log base 5 of x squared minus log base 5 of 6. All right. So the first thing I see there is I've got an addition sign between those two. So I'm going to put those first two there together using multiplication. So log base 5 of w to the third times x to the second. And then I still have a minus log base 5 of 6. Now I'm seeing I've got this subtraction sign in between it. What does subtraction mean with logs? That means division. So let's put it together as a single log now using division. So I've got w to the third times x squared over 6. So there it is as a single log. Letter C down there, we're supposed to expand those out. So expanding those out, we've got multiplication up there at the top. So let's expand those out. We've got log base 5, and we've got x squared, and then I'm going to put plus log of y to the third, and I'm going to put a minus because I've got that square root down there, so minus log, whoops, forgot my base 5, base 5 of a square root of 3. All right, supposed to expand it so all the powers have to come out. So remember, don't forget that this 3 here is the same thing as 3 to the 1/2. That's square root of 3 there. So it becomes 2 log base 5 of x plus 3 log base 5 of y minus 1/2 log base 5 of 3. And there's nothing left to simplify on that. We can't simplify that log base 5 of 3 over there. So we're just going to leave that like that. 2 log base 5 of x plus 3 log base 5 of y minus 1/2 log base 5 of 3. So now we've got this change of base formula here. We talked about this yesterday. If you got the log, if you don't have that log base on your calculator, you can use a change of base formula. So this is just written out. So yesterday we had something like log of base 5 of 15. We changed it into base 10 here, log 15 divided by log 5. That's essentially what this formula is saying. Or some of you were having a hard time with your log button on your TI Inspire. You can go ahead and use natural log as well. You could do the natural log of x divided by the natural log of a, or a natural log of 15 divided by a natural log of 5. So that's the change of base formula that we're using for those of you who don't have log base on your calculator. So now let's go ahead and let's use our calculator and evaluate to 6 decimal places. So if you're going to use your change of base, this is what you would do. Log 12 divided by log 2, or some of you use natural log of 12 divided by your natural log of 2, or some of you go onto your calculator and you go underneath the math button and you scroll down and you go down to log base. And then it will put in your screen, it will do log, and there'll be a little square there and a little square there, and you're going to fill in your 2 and your 12 there. So as you're doing that, we're going to round that out 6 decimal places. We're looking for 6 decimal places on that. So going out 6 decimal places on that, I've got log 12 divided by log 2. And I'm getting 6 decimal places, 3.58496. And then there's a 2 and then a 5. So this is a 2 and this is a 5. If that number over here is 5 or larger, you need to round it up. So if that number there is 5 or larger, you need to round that 2 up to a 3. Since it is, they're going to round this up to a 3. So this is no longer 2.5, it is going to just be a 3. So that is 1, 2, 3, 4, 5, 6 decimal places after the decimal point. All right, so now we come down here. This is the log base 9 of 3.28. So go ahead and put that in there the way that you are going to enter it into your calculator. So I'm getting about, going out 6 decimal places, I get 54061, and then there's a 0, and then there's an 8. That 8 is going to round that 0 up there to a 1. 5 or larger, we're going to round it up. So this becomes a 1, 1. So 54061, because that 8 rounded that up. That's 6 decimal places. 6 places after the decimal point. 1, 2, 3, 4, 5, 6. 6 decimal places. So we went ahead and we evaluated log expressions. We used the law of logarithms to expand or combine logs. And then we use a change of base formula, or you've got your log base on your calculator to evaluate a logarithm. And then we rounded our answer out to how many decimal places we were asked to do. So there's your assignment, and then you can go ahead and get going on that.